I would like you to introduce yourself a little bit more than I did and take it away. You can show your screen. Share your
Okay,
screen.
well, great to be here with everybody. I'm going to share my screen. Um, can you see that okay, Diana?
Yes, I can.
Okay, so welcome everyone. It's really great to be here. I spoke last year on the challenges of getting the course approved for being a course this year at Ida B. Wells High School in Portland, Oregon. So I'm going to talk about some of the um, uh, cool things that we did this year, and then some of the challenges that we ran into as a class in a first year systems course. That's kind of our outline here. So my name again is Thor Esbensen. I've been teaching high school mathematics in Portland for 25 years. This past year was the first time that I had the pleasure of teaching a um, full systems modeling course. As Diana said, I have been uh, integrating some systems modeling throughout my years as a teacher, but this was the first year as a standalone class. And I have to mention, the students were so excited that I was going to share a picture of them in the presentation. So that's our classroom there that they're having a great time with. Really quick, those tables that they're working at are whiteboard tables. So they do a lot of their modeling on the whiteboard table before they go onto their Chromebook, which is a kind of a cool side note for what we're able to do. Um, I'm going to use the word we a lot, meaning myself and the class. Learned a lot during our first year. There were some things that went really well for us that I'll go over, and also some things that adjustments that I needed to make as an educator as I got to know my audience and um, the way that students wanted to learn systems dynamics. Um, I'm pretty optimistic that we'll continue this class in the future, and I'll talk about some of the ways that I want to kind of improve the course as we go on. So, one of the first things that I had to do, and Diana Fisher is a mentor of mine all the way back from when I started teaching at Ida B. Wells uh, 25 years ago. And now is a mentor for me with this implementing the dynamics course. So I was seeing a lot of references to systems thinking showing up in news articles that I was reading in terms of what businesses were looking for in employees, what colleges were looking for in students, and trying to adapt our math thinking to a more modern scenario. We've been so locked into this 1855 decision that Harvard made, and we just haven't broken away from that, even though our world is entirely different than when those decisions were made. So, was fighting for this, and a wonderful coincidence that Diana reached out to me to say, "Hey, we're really trying to get this into high schools." And I said, "Let's go! This is amazing. Let's make this happen." So kind of had to create like a basis for the class, combining this modeling language. We chose using Stella and systems thinking at large. So the curriculum we chose was actually Diana's, which is the model dynamic systems. There's a picture of the cover there. In the book, I have it linked at the bottom if you want to look into what she built for students to get them up and running with some incredible models. I had to think about what were the expectations of the students, like what were we trying to get out of this? What's the end goal here? Some of the things I didn't think enough about were like expectations for grading. I was so excited about the global impact of like systems thinking and being a dynamic modeler, and then I had to get stuck in the minutia of like how do I grade them? How do I assess their learning? What I landed on was explaining to them that we're going to be a little bit more like a startup company, like a working relationship, where they were going to do some work and turn that in. I was going to reflect on their work and return that to them with the hope of them improving uh, their work. So kind of more of a flow grading diagram where they would submit stuff, I would return it. and give it back. So that was one thing that I emphasized. Another thing that I put into the grading component was they have their models that they built, and I'll get into some more of those. Diana's curriculum has them kind of build different types of model relationships in kind of a compact form. And after each of those learning kind of target models, I would give them basically a quiz. But I told them it was basically more like a business might do. They might give you like an assessment for understanding. I would look at it, give it back to them. They could redo it and turn it back in just to make sure that they had the language correct and had the key ideas in perspective. And then, obviously, I mentioned that we're using the Stella modeling system as a language. Okay, so some of the things that went well. I was really surprised by how engaged the students were in their learning. I teach everything from Algebra 1, 2, up through second year calculus in the high school. And the level of engagement, the excitement that the kids have for discussing what they're doing was just over the top in this course. I haven't had the depth of conversation about mathematics in the other classes that I was able to have this year. It was it's very fatiguing because you're having deep conversations regularly throughout the course, the class period. But it was exciting because they were having really quality, deep conversations as we went on. Their modeling process went really well. They went from a basic stock flow diagram that I have demonstrated up here on the top to some really invested, deep modeling that Diane had laid out in the curriculum, which they were doing some really deep thinking. And it was neat as we went through the models, they inherently started building the models through our conversations. Here we have a pollution model, and we started very basically with a population and a pollution. And with the feedback loop would be that the bigger the population, the higher the pollution, and the higher the pollution, the higher the death rate, so the lower the population would go. And we had a student argue that, well, why wouldn't we be treating the pollution? Like, why wouldn't we be treating that? So we built in the treatment, which was the next part of the model. So they progressed really well through the year, identifying the different interactions in the greater system. There was a ton of peer tutoring. They did a really great job of communicating with each other, challenging each other. The conversations that I overheard them having with each other was amazing, and kind of talking through some of the things in their models, whether it was kind of a more aside to like, well, why was that happening? Whether it was, well, I think it should go this way versus this way. I appreciated a lot of that peer tutoring that we saw. We encouraged the students to work in pairs. So they did a lot of great group work together. So there was pairs that worked together, and then those pairs would work with other pairs, which brought together a lot of healthy debating in the class in terms of trying to come to a common agreement about, does that even make sense to have that? A lot of it came in the form of working with dimensionless multipliers, kind of meaning effect of one result on another result. In the model we have on the screen here, you can see we have a model of an effect of the pollution on the death rate. And so they would have really great debates about how much of an effect did we think that pollution would have on death rate, and got a lot of back and forth there. We also, another thing that went really well for our course was having speakers come in. We were so lucky to have Miss Fisher come in and talk to us about her experiences as a modeler and a teacher of modeling. We had a outside resource, Rich Coffee, he would come in and talk about he's works in AI with Amazon and was coming in and talking to them about his experiences with systems in the greater context that he works in as at Amazon Web Services. We had another presenter come in and was talking. He works at Lawrence Livermore Lab and was talking to them about how he was communicating. He did a project where he was trying to get farmers in Africa to vaccinate their cow herds from diseases, and like how he approached that, and ended up not knowing Stella, but drew essentially a Stella diagram on the board for the kids so they could see the real world transition from class to the outside world that they're going to be entering. Right now, we're doing some independent projects. We had them do earlier in the year a independent project kind of reflection, like how could I find something in my world that I am excited about, and how would I look at that from a systems perspective. Now they're actually building a model off something they're interested in, and those conversations have been really, really beneficial to the students. I've been really excited about the way that they're thinking about their independent projects. We have a student, she's a wonderful young woman, and she was looking at the difference between wealth taxes and income taxes. And she was shocked that when she kind of created this model that we could essentially tax these billionaires and they still make more money in their bank accounts, but we can fund public education and healthcare. When she kind of modeled this back and forth between percentages of wealth and where we could put that wealth. So lots of cool ideas that kids are kind of generating out of the independent projects as well. But real quick, some of the favorite projects that they reported back were we did drugs in the body. So they looked at the difference between taking having an IV drip component versus taking a pill form, and the difference between getting the drug directly into the body versus going through the stomach and then into the body. They really enjoyed the population collapse model and had a lot of great conversations about climate change and should we be more proactive in the climate change engagement. We went through an epidemics model that they were really excited about. A lot of them were excited about how epidemics are like memes in the real world, where you have people that are able to accept the meme, clientele, and then that clientele evaporates over time, kind of like an epidemic will with healthy people and susceptible people. They had a great time with the urban dynamics model. We looked at how a city works in terms of the available land and use for different things. At the end of that model, we looked at a comparison between Portland, Oregon and San Francisco, who had similar density policies, and what the difference was between those policies that led to one being fairly successful and San Francisco far less successful. So kind of tying again, the class into the real world. Here you can see an example of the urban dynamics model that's on the slide there. Supply and demand was one that they got really excited about. Our economics teacher came down and was asking me about the excitement that they had about supply and demand after doing the model. And he was really impressed with the level of knowledge that they were gaining from doing that model. And we ended with a pollution model, which again, they were very excited about that back and forth nature of that push and pull of more people, more pollution, less people. And kind of there's some healthy debate about the effect that they thought pollution would have on the population. It didn't all go great. It really didn't. We had a lot of things to kind of work out. So things that we adjusted kind of on the fly as we went through the class. We had started with a much more independent idea. So I would give them the work packet from the curriculum that they would kind of work on, and I would go and kind of problem solve with them through their modeling development. they didn't actually really like that much. And I'll circle back to that in just a minute. We also had a lot of late additions to the class, which disrupted kind of like the whole class flow. So I think I needed to incorporate a little bit of a, how do I get kids up to speed problem solving. Then we had the students really preferred working as a large group for like the major modeling part, and then kind of breaking into do the analysis of the model. So they liked building the model together and then running the analysis in smaller groups. So that was something that I adjusted to kind of like, hey, let's build together and then break off for analysis. They really were more engaged when we worked as less as independent groups kind of building their models, and more as a conversational class modeling project. And then one of the things that we had to keep talking about was referencing the Stella modeling as a language that they're learning, and reminding them that as learning a first year language, if you're in first year a Spanish course, you're not going to go to another country and feel like you're fluent. And so reminding them that yes, you're acquiring the language of Stella as we go through the year. And it might not be that everything is intuitive, but you're acquiring the language, and it can take a couple of years to feel like you're fully able to model complex situations with Stella. One thing that I was happy that we did is a semester reflection. I asked the students to do a project at the end of the first semester where they, through various means, did a reflection. And it could have been an advertisement for the course, like, hey, this is why I like having this course, we should keep doing it. It could be a reflection on one of their favorite models, like, hey, I really like doing this model and here's why. Or it could be a critique of the class. And got some really valuable feedback from them about how they were accepting the learning of the course. So some things that I want to change in the future as we continue this course going forward. I'm going to try and figure out a way to kind of create some more resources for making up absences. Whether I like it or not, absences exist in our school, in that really we're on a block schedule. So when a kid misses 90 minutes of classwork time for an absence, there's a ton of learning that happened that you can't just step over. And that goes for many courses, but especially in this one, I need to find a way to help them get back on track if they do miss some of the instruction. I do think I'm going to do video demonstrations of the models, for students to reflect on, to have as a resource to go back to that building portion of what we're trying to get them to understand. I'd like to do more of these check-in assignments to make sure that they're really understanding the language of systems and understanding the importance of those systems as they go through the course. I was talking with Diana about splitting the modeling into, like, let's work together to create this model. Now we want you to use the same ideas to create your own model. And so I'd like to create a little bit more of a, let's do this together, let's do this independently. I definitely want to spend more time at the beginning of the year. The previous speaker spoke to this as well. Just thinking about systems thinking prior to introducing the language. So I think I'll probably have like a 2-week initial introduction to just systems thinking on its own before we introduce the language of building a system in the Stella language. And I'm also super excited about the integration of the Stella AI. So we're going to start in the next, maybe about a month, we're going to have the students start looking at the Stella AI and how can we successfully utilize that package that Stella has been building into their language. So looking forward to that as well. So I'm going to wrap up with some challenges and excitement about keeping a first year course going. It is an elective course, and I'm optimistic that we'll get things to continue to go. This year we had 2 courses, 2 classes, each with about 25 students in them. But the state of Oregon has instituted a new required senior level course, which has taken away one of the electives that the students were afforded before. So our numbers did drop this year. I thought we had about 60 kids ready to take the course next year. That dropped to about 23 in actuality. We also have a massive budget deficit here in Oregon, I think around the country as well. But we're about 50 million short on funding for next year. So there's also a reduction in funding. Those two things together have put a big pressure point on elective courses like the Systems Dynamics course, amongst others in our school as well. I need to do a better job recruiting moving forward. And like I said, I had about 60 kids committed to taking the course, but they didn't show up in the numbers. And so I need to figure out how to make sure that we're making this course available to students and demonstrating the importance of the course. I'm hopeful that now that we have the course up and going for a year, that our projects that the kids are doing is really going to speak to the community. So kind of advertising the what the students have done this year and getting that out into the community will build that. Social inertia is important. Momentum is important. And it's hard to develop momentum and social inertia in a singular year. So working on those aspects. I want to keep fighting for a continued emphasis on diverse course offerings. Again, I love the quadratic formula, but I think the world has changed and we need to meet that changing world. And so I'm hoping that this level of student engagement, the way that systems can engage students in their own learning process is important. And I think that the AI situation has arrived. I don't want to call it a revolution, but I want to say that it is real. And we have a lot of conversations with the kids about this is here. How do we get ahead of it? We want to control it as opposed to getting replaced by it. And so that's some of the things that we're excited for and some of the challenges that we meet. So, Diana, hopefully I didn't speak too fast there. Are there
No,
questions
I
that
think
people
that's
might
great.
have?
You want to stop sharing?
I'm working on it. There it is.
Yeah.
Okay.
Okay. Great. Thank you very much. Um, Being able to have the privilege of teaching a standalone course is not going to be very typical for most schools. Most schools, we're just trying to incorporate it in the regular classroom, but teaching a modeling course adds a whole lot of depth for students and what they can experiment with. So it's pretty cool. Do we have questions? Henny, you have a question for Thor?
Yes, can you hear me?
Yes, we can hear you.
Okay, that's great. Yeah, I don't have a camera on at the moment. I'm going to change my setup later on, so no worries there. I was wondering, Tor said that he was thinking of introducing AI in order to be able to do faster modeling. And at the same time, he said that students had a learning curve to learn the language. And that made me think, is it wise to introduce AI for faster modeling? Wouldn't it be better if they would go slower and then be able to learn the language better?
Yes, you are absolutely correct. So some of the students noticed the option for AI, and we had some really deep conversations about being responsible users of AI. And we talked quite in depth through the course about we can't use the AI component of Stella because we don't know what it's doing. And if we don't have the language at a level that we can harness the power of Stella, uh, um, utilizing the AI is just it will be frivolous. It wouldn't do us any good because we wouldn't be able to check the understanding of the AI modeling that it did. So the AI modeling in Stella is not at a point where we can just utilize it without knowing the language. So you are absolutely correct. They need to know the language first, and then they can potentially use the AI as a resource as they move forward their modeling. And what I would encourage the students to do if we get to that point, would be to build some of the simple models at the beginning, and then have them build very small, simple models with the AI, and then they would be the ones that weave together the simple models in a more complex way. But I would really discourage them from just asking the AI to do something for them. It would be more of a streamlining
Yeah.
of their base models.
Yeah, yeah. Since I'm working with a little older group of students with more basic skills, and what I introduced an AI prompt to them that I made myself, and I warned them that they first need to do the thinking themselves. And what I found was that they were really looking for the right answer, and you don't want them to look for the right answer in the stage that they are thinking it over. You want them to think it over. So that was a real a caveat that I noticed when I introduced that AI prompt to them.
Yes, and Henny, we were very fortunate with our speakers. All three of the speakers I mentioned have really quality experience with AI, and so we were able to kind of harness some of their understanding of AI. And all of them were very direct with the students, like using AI to do fairly mundane tasks is a benefit to you. Using AI for creative generation is not a good idea for you. And so that we were trying to draw a very clear line with the students about utilization of AI. And each of the speakers spoke to that um, there is some benefit to having these AI models out there, but that these AI models should not replace either your creativity or your learning process. And so if it's something that starts to get in the way of your learning process, that's not a benefit of the AI learning models. So we had numerous conversations throughout the year on that, because that's a reality that they're walking into. And so I hope that answers a little bit there. So we have not.
Yeah, lovely. Thank you.
Yeah, in this I have told them, like, no, don't use the AI yet until we know that we can check the AI as a language.
Thank you for your answer.
Anyone else like to ask Thor anything? Thank you, Thor, very much. You really gave us a good overview of what you've been doing this year. And next year, hopefully, with the class again, you will refine what you're doing, as is true. My second class of teaching a topic is always better than my first one. So I really appreciate your sharing what worked well and what did not work well for you during this process. And the whole AI thing, AI makes mistakes and they give you things you may not want. So students have to develop some skill in model building so they can be critical of what AI is giving them. And since it is also new for all of us, we are just trying to figure out the best way to use it as teachers do. It's only coming a whole lot faster than before when we had
Well,
some innovative changes. So thank you, Thor. I really
well,
appreciate your giving us your time to do this presentation.
Well, then I'd like to say one thing about the class. I periodically thank them very deeply for taking the chance to engage in a first year class of this nature. And I think it's important to always thank the students for their interest and
Yes.
engagement. They didn't have to sign up for the class; they chose to, and I'm very grateful for their adventure with me in that first year learning.
Well, and they like you as a teacher. You are very popular, and they are willing to take this chance because they have respect and admiration for you as a teacher. So that also helps. So
Well,
that's
thank you.
great. Well, okay, I have to stop recording.